Hello everyone. This is going to be the last video in the series of roots, and in this one we are going to be discussing cubic roots. So if you've been wondering why I kept saying square roots and not just roots, here we will find an example of a root that is not a square root. I am, however, going to be mirroring what we discussed with square roots, so I'm going to start with what is a cubic root. Then we will look at some examples of cubic roots. We'll go to negative or opposite cubic roots and finally end with approximation and exact answers. So to start, let's remind ourselves with square roots, we had this diagram where we saw that a square root is the opposite of the power of 2. And it was also a number, the results of this calculation. Cubic roots work very similarly, but this time it has the power of 3. So the cubic root of, let's say, 8 answers the question of what to the power of 3 equals 8. Or alternatively, if a cube has a volume of 8, what are the sides? So that is the idea of a cubic root. Let's have a look at some examples. So we just looked at cubic root of 8 as an example. Something to the power of 3 is 8. That's 2. 2 times 2 times 2 is 8. Cubic root of 64. Well, that's not 8 because that's the square root, but actually 4 times 4 times 4 is 64. So the cubic root of 64 is 4. 121, it might start to get a little big, but well, we know it probably has to do something with 5, and indeed 5 to the power of 3, 5 times 5 times 5, 25 times 5 is 125, so the cubic root of 125 is 5. And one last example, cubic root of 216. Again, you don't have to memorize these all, but this one is going to be 6. All right, so that's just a few examples of what it does, what happens. What happens now with negative and opposite numbers? So let's again start with an example with a positive number. So the cubic root of 27. Well, 3 times 3 times 3, 9 times 3 is 27, so this is 3. But what happens this time when we have a negative number in the root, in a cube root this time? Well, now something else happened. In a square root, this was not possible, but in a cubic root, minus 3 times minus 3 times minus 3, that's minus times minus times minus. That still leaves a minus. So this is actually minus 27. It is minus 3. So with cube roots or with cubic roots, negative numbers do exist. So in this case we can, and it is just minus 3. Lastly, what about the opposite then? Minus cubic root of 27. Well, this is also minus 3. We still first calculate the roots. Cubic root of 27, that was 3, and then we add the minus. So again, it's just the opposite of the cubic root of 27. But this is the special thing here, that it does work for negative numbers as opposed to square roots. Okay, so that's the negative and opposite stuff. How does approximation and exact work? Well, it works the exact same way as with square roots, because approximations and exact answers are not limited to square roots. These are just general mathematical concepts. So for any mathematical question, you may have to answer an exact answer, then it has to be precise and be perfect. Or you may have to answer an approximation, and then you answer a decimal number. So this is nothing new, so I'm not going to go into this. The only thing I want to point out is how you can calculate the cubic root on your calculator. So that's going to look something like this. And the cubic root is actually hidden over here, a very small thingy above the power of 3 button. So what you're going to have to do is you're going to press Shift, and you can just let it go afterwards, it remembers. You press Shift and then you press x to the power of 3, and then you get this cubic root. Of course, this is only the case if you have a Casio, like I do. With a different calculator, you may have to find the option yourself. But anyways, that is all I wanted to say about approximations and exact answers. So with that, I'm going to round this off. And I hope this helped you figure out what the cube root or cubic root of a number is, and how you can use your calculator to give an approximation of a cubic root. And now let's start working with these.